Okay, now we are in example 5. I decided to go ahead and skip example 4 because the practical application in that particular word problem was not my favorite. So recall that our first step is to step 1 is to factor. So when we factor the top, that's the difference of 2 squares. And I'm actually going to do this down here below this. So we get the square root of 4x, which is 2x minus 3, and 2x plus 3. And then our bottom is going to be x plus 5 and x minus 3. So we factored that completely. And when we do the extra examples that I've given you that you can put in your notebook or not put in your notebook, I don't really care which way you do it, you're going to see why it's important to factor first. So to determine the vertical asymptote, we set our bottoms equal to 0, x plus 5 equals 0, x minus 3 equals 0. So x equals -5 and x equals 3. I'm going to draw those on here in blue. And generally, whoops, you should really put these on as dotted lines. So just pretend that other blue line is dotted. Now, for our horizontal asymptote, you'll notice that the powers on the top and the bottom are both 2, so they're the same. And when they're the same, our horizontal asymptote is at that ratio of the top to the bottom, which is 4 over 1, 4 over 1, or just 4. So now I'm going to put my horizontal asymptote there at 4. Now, you'll notice we've got 2 asymptotes. So this doesn't look anything like what we've done so far. So what I'm going to do is I'm going to plug in some values to the equation in each spot. So in this spot, and this spot to kind of see where my graph is. So if I plug in 4, so 4, if x equals 4, we get 2 times 4 minus 3 times 2 times 4 plus 3, which is going to give us 5 times 11, which is 55, over 4 plus 5, which is 9, times 4 minus 3, which is 1, over 9. So this is going to give me some positive value that is almost 6. So we're going to have 4, 6, which means that this graph goes like this. Now our graphs are always approaching the asymptotes. So it looks kind of like that. The easiest number to plug in this middle section is 0. If I plug in 0, I get -3 times +3, which is 9, and 5 times -3, which is, or excuse me, -9, which is -15. So that is going to give me +9/15, or 3/5, which is going to be here. So in this case, our graph is going to go like this. Just going to be that U through that point. And then finally, our last area that we want to plug in is over here with this like -6 or -7. So I'm going to do 2 times -7 minus 3 times 2 times -7 plus 3 all over -7 plus 5 and -7 minus 3. So we get -10 times -2 over here, which is +20 on the bottom. And again, you guys do this all on your calculator. I'm doing it out here because I don't have a calculator handy, but really don't do that. This is going to be -15 times -11, which is going to give us like +100 and something, which is going to be way more than 5. So that's going to put that one up here in this corner. So that's what our equation looks like And this part down here, that was just to, good gravy. This like black blob down here was just kind of denote where those sections were as we were choosing numbers. So our last step in 3, whoa, where did our steps go? Or here was to check a point in the domain on every side of the asymptote to see where the graph is. And we're going to see more examples of this. I didn't want to leave you guys cold, so we're going to do some examples. So first and foremost, we're going to factor this. So in factored form, we have x minus 2, x plus 2 over x squared. We have our vertical asymptote is where x squared equals 0. So that's where x equals 0. So we fall right here. Oh my goodness. I love when it does what it wants to do. So we have that vertical asymptote at x equals 0. Then our horizontal asymptote, our squareds are the same. And so it's just 1 over 1 or 1. So we graph. Here's our asymptote. Now, if I plug in positive 1, for example, to get my part to where my graph is, I'm going to have 1 minus 2 times 1 plus 2 over 1 squared. So when I get that, I get negative 1 times 3 is negative 3 over 1 is negative 3. So here we would put 1, negative 3 on our graph. So that tells me that our graph is going to look like this. Then if I plug in negative 1, there we go. Change it to red. Now if I plug in negative 1, I get negative 1 minus 2 times negative 1 plus 2 all over negative 1 squared. So that gives me negative 3 times 1, again, is negative 3 over 1. So I'm going to get negative 1, negative 3, which is this point, and then my graph looks like that. So in this case, our end behavior at that asymptote is the same in both directions. Okay, now this next one is going to introduce a new concept for us. So first, we're going to factor it. We get x plus 1 over x plus 1 times x minus 1. And what you'll notice is that this part here matches this part here. So what happens is that when we are looking at our vertical asymptotes and we get x equals negative 1 and positive 1, that right here, this one here, because it cancels in the top, those can cancel because they're exactly the same. So that means that this is not a vertical asymptote. It is actually a hole. So negative 1, there is a hole. We're going to talk about what that looks like. So when we cancel that yellowed part, our function actually becomes 1 over x minus 1. So then our vertical asymptote is at positive 1. So right here. And then our horizontal asymptote, because this is bottom heavy, is going to be at y equals 0. So right here. So now you're thinking, what do I do with that hole there at negative 1? Well, to find the value for the hole, we're going to plug that value of our hole into our modified equation. So we're going to get 1 over negative 1 minus 1, which gives us 1 over negative 2. So at our hole, we're going to have negative 1 and 1/2. So we're going to make an open dot there to show our hole, and then our equation looks like that. When I plug in 2, I get 1 over 1. So my other point is at 2, 1. And it looks like this. Oh, that's negative 1/2. Ooh, I messed up. Shocker. I know. You guys are so shocked.